right, today we're starting Chapter 3, Section 2, log functions and their graphs. We're going to evaluate them and apply the properties. So it's just the day one introduction to logs. What we know about log functions is the inverse of exponential functions. The definition for x greater than 0. That means that x has to be, x is positive. And b is also positive and not 1. If and only if f equals b to the y. So you can take it from exponential form and write it into log form, and vice versa. You can take it from log form and write it into exponential form. It's called the log function with base b in this case. We're going to practice writing each in log form. Log form and exponential form, the name of the game is the idea that you have to match the bases. So if my exponential base is 3, my log base also has to be 3. 3 to the 6th power equals 729. So 3 to the 6th power, by definition, equals 729. Idea applies the same here. Base 10. Log base 10 to the 0 power equals 1. Match the base. Log base 5 to the 2nd power, 5 to the 2nd power equals 25. And then last but not least, my base, you can have fractional bases, you just cannot have negative bases. Log base 1/2 to the 3rd power is equal to 1/8. You can also go the other way. You could write it in exponential form. My base is 7. 7 to the 0 power equal to 1. Again, match the base. 17 squared equal to 289. 12 to the negative 2 is equal to 1 over 144, or 1 over 12 squared. Moving on. These get a little bit more complicated. Again, the idea is matching the base and using one of the properties that we will learn. The property that we're looking at is if the log base b and this base match, then it's going to equal whatever the exponent is. So that's one of our properties that we're learning. Log base b, b to the x, see? B to the x equals b to the x. That's why it works. So if I'm going to substitute log base 2, and I'm going to substitute 32 in for x, what I want to try and do is match my bases. So I'm going to look at it and say, okay, what can I do? How can I change 32 to base 2? Well, 32 is 2 to the 5th. So that's going to equal 5. This one, log base 3 of 1. How am I going to change 1 to a base 3? Well, 3 to what power equals 1? 0. So my solution is 0. Now these last two are a little bit more complicated. Okay, so we're looking at log base 4 of 2. Now how do I change 2 4 to some power? Well, that's where it gets a little more complicated. We have to go back to our knowledge of square roots. Okay, so the square root of 4 we know is equal to 2. That's what we want, is 2. But what power is that? That is 4 to the 1/2 power. That means square root of 4. So my solution, not 2, my answer is 1/2. So they get a little bit more complicated. What about this one? So here we're going to substitute log base 10. Well, how do I make that fraction of 1/10 to base 10? Well, it's a fraction. So a fraction means I have probably a negative exponent. If I do -1, that means 1 over 10 to the first. So my answer is -1. They get more complicated as we go along. Let's look at a few more. Log 464. Again, let's match the base. 64 is 4 to the third. That equals 3. Let's match the base. These two are pretty easy. 10 squared is 100. It's 2. Now, this one's going to be more complicated. Log base 32. 32, what? That's bigger than 2. So what I'm looking at is 32 is bigger than 2. I probably have to take a root or something of it. So I come over here and I'm like, okay, 32 does not have a perfect square root, but 2, let's break this down. Look, how many 2's do I have? I have 5. So if I take the 5th root of 32, it's going to equal 2. But when I rewrite that as an exponent, what does it become? It becomes a 1/5 exponent. Number 4 is a lot more challenging. Decimals are harder. What I'm going to do is I'm going to take this decimal and I'm going to rewrite it as a fraction and simplify my fraction and see what happens. Okay, so they're both divisible by 125, so that becomes a fraction of 1/8. So I can rewrite this log base 2 of 1/8. Well, that doesn't help me because my bases don't match. So how do I make 1/8 to a base 2? Well, it's a fraction, so I probably have a negative exponent. 2 to the third is 8, so it's going to be -3. So my answer will be -3. Common log. This is what messes most people up. A logarithm that uses base 10. If it is not written, it's assumed to be base 10. That's like a coefficient on x. If it's not written, it's assumed to be 1. Most of our calculators, not all, but most calculators only know how to evaluate with base 10. We'll deal with those properties later. So now we're going to play with our calculators, and we're going to evaluate this. F of 10. Well, it's base 10. This is 10. That's calculator. That one you should be able to do without a calculator. This one, probably not so much, because I don't know how to convert that to base 10. So I'm going to put this in my calculator, and I'm going to get an answer out that is approximately 0.398. What if I put in f of -2? If you put that into your calculator, you may get an error, domain error, syntax error, something like that. Why? It's undefined. We cannot take the log of a negative number. What about f of 1? So we're taking the log of 1. You put in your calculator to get 0, but you should know that. That's one of the properties that we need to know. Okay, so here's some of our properties. We already looked at this one right here. Okay, we already used that one. So, but what these are going to be used for. These two will be used mainly, not solely, to graph logs. These two, again, not solely, will be used mainly to simplify and or solve. So let's look at some beginning solves. All right. Do my logs, do they have matching bases? Yes, they do. So what does this x have to equal? X is going to equal 3. Matching bases on both sides, therefore they have to have the same log. We've looked at this one already. 4 to the first, so x is going to equal 1. What about simplifying these? Well, they have the same base, so that has to equal x. These simplify, same base, so this is going to equal or simplify to 14. I want to add just one more question. What if I have for 16x? Well, let's look at that. What can that be changed to? Change to base 4, correct? 16 is 4 squared. I still have an x up there. So this is going to then simplify to 2x. Just one more additional